In this tutorial, we will focus on inverse by using Gaussian elimination. Definition: the inverse of a square matrix A, of order n, is denoted by this symbol, where the product of A and inverse of A is equal to an identity matrix of order n. The inverse of A is also a square matrix of order n. Please note that the matrix A must be a square matrix. Otherwise, its inverse will not be found. Examples of operation: any constant k can be multiplied to all the elements of one row. For example, k is multiplied to all the elements in the first row. You can add one row to another row. For example, the elements in row 2 are added to the corresponding elements in first row. You can subtract one row from another row. For example, the elements in row 1 minus the corresponding elements in row 2. Any constant k can be multiplied to all elements of one row, and add one row to another row, or subtract one row from another row at the same time. For example, k is multiplied to all the elements in row 2, and then adds to the corresponding elements in row 1. Any two rows can be exchanged. For example, row 1 and row 2 have been exchanged. Operations: above operators can be expressed in terms of matrix multiplication. For examples, sum of two rows can be expressed in terms of this multiplication. Subtraction of two rows can be expressed in terms of this multiplication. To multiply k to the elements on second row, and then add to the corresponding elements on the first row, these operations can be expressed in terms of this matrix multiplication. Exchanging the first two rows can be expressed in terms of this multiplication. Operations of similar types will be associated with n, e, I, of similar form. Here is the main idea of inverse. If we can find some operators e1, e2, to en such that this is equal to an identity matrix, then inverse of A is equal to en times en minus 1 to e1. To compute the inverse of a matrix A, the steps are shown below. The first step is to write the two matrices A and I in this form. Then, apply two types of operations to both sides of 1, until we get this form. There is an identity matrix on the left-hand side. Therefore, B is the inverse of A. Here is the proof. Examples: we are now going to find the inverse of A. First write in this form. Then the elements in row 2 minus the corresponding elements in row 1, such that it will become 0. Then the elements in row 1 minus 3 times the corresponding elements in row 2. Finally, we get the identity matrix on left-hand side. Hence, this is the inverse of A. Here is another example. We are going to find the inverse of A. First write in this form. Then the elements on row 2 minus the corresponding elements on row 1, such that it will become 0. Then the element on row 3 minus 2 times the elements on row 1, such that it will become 0. Then replace the elements on row 2 by the negative of the elements. Then row 1 minus 2 times row 2 and row 3 plus 2 times row 2, such that these two will become 0. Lastly, row 1 plus 2 times row 3, and row 2 minus 4 times row 3 such that there will be an identity matrix on the left-hand side. Hence, it is the inverse of A. Exercises. Here are some exercises. Try to do it now, and see how well you understand the topic. This is the end of the tutorial. Thank you.